Hello again, Year 10. Today we are going to be looking at how we solve a quadratic equation. Now we have done this before in Year 9 for quadratic equations where it was 1x squared. So some of the maths that you see today will be very familiar. And we're also going to be using the skills that you've been developing over the last two lessons in terms of factorising a quadratic where there is a coefficient of x squared. So I thought we'd start with a little puzzle today. Can you place each of the numbers 1 to 9 in the boxes so each of the sides of the triangle add up to 20? Give yourself maybe 3 or 4 minutes, see if you can puzzle this one out. I will be back with the solutions in a moment. So as you can see, there are several answers to this problem. I'm just sharing a couple of them with you. I think one of the common themes is the corners have to add up to 15 for this to work. So on to today's lesson, we are going to solve a quadratic equation of the form ax squared plus bx plus c equals 0. But first of all, I'm just going to remind you of a few of the things from Year 9. Now, one thing that you need to remember is a quadratic equation is very special because it usually has two answers, and we can call those answers solutions. One approach to solving a quadratic equation is to factorize it. So you can see now why that factorization process is super important. If we have factorized a quadratic and those two brackets multiply to make 0, we can then take each of those brackets separately and make an equation with those saying that one of those is 0. If you think about it, if two things multiply together and it makes the answer 0, one of them has to be 0. So I'm just going to take a moment to go through a typical example from Year 9 just to remind you about how we set these out. So for example, I have solve x squared plus 3x, take 40 equals 0. The first step is to factorize your quadratic. Okay, and since this is a Year 9 example, there is no coefficient of x squared other than the number 1. So populate an x in each of the front parts of the bracket. We're after numbers that multiply to make negative 40. And the combination that we need is 5 and 8. 5 times 8 is 40. They have a difference of 3. To make it positive 3 with different signs, I need a plus 8 and a negative 5. So that is the factorization. Then, if these two things multiply to make 0, one of them has to be 0. This is where my class wouldn't have liked the fact that I made them write a little bit, but I'm not exactly asking you to write lots. So either this equals 0 or the other bracket equals 0. And then remember, this went on to give us two answers. If x take away 5 is 0, x has to be 5. And if x plus 8 is 0, x has to be negative 8. Well, what you're going to see today is very much the same process going on. Factorize, find your two solutions. Sometimes finding the two solutions can be a little bit trickier, and the answers that we get aren't always integers. So let's have a look at the first of 4 examples. I'm still going to go through the factorization process just in case one or two of you have struggled with that. So do listen carefully as we're working through each of these questions. So we have the quadratic equation 2x squared plus 7x plus 5 equals 0. And my first job is to factorize it. So what you have been doing for the last 2 lessons. I'm going to list the things that multiply to make my first, which is only 1 and 2. I'm going to list the things that multiply to make my lasts, which is only 1 and 5. So I can start populating some of this. I know it has to be 2x and x. I've probably also spotted that the signs are both going to be addition. But how is it going to multiply to make 7? Well, 2 times 5 isn't going to work because that's going to be 10. So the 2 needs to times by the 1, and the 1 needs to times by the 5, and that will be 2 and 5 that will make 7. So 2 multiplies by 1, 1 multiplies by 5, and the signs are both add. I'll put equals 0 on the end. So that's the first step, factorise. And then from there, it's very much the same. It's either the first bracket equals 0, or this second bracket equals 0. But you can see it's super important that you get that factorisation right, because if that is wrong, everything that follows will then be incorrect. And you might see this when you're marking some work, if your signs are different, for example, to mine. Now, this bracket and equation is relatively easy to solve. That one is just x equals -1. Some of you might be able to solve these in your head, or with a little bit of practice, see how to do them. But I'm going to do this one in 2 steps. First of all, if I want to get the x by itself, I would subtract 5 from both sides. So 2x is -5. And then I would divide by 2. So x is -5 over 2. I'll just write what I have done. I've subtracted 5 and I've divided by 2. Now, 1 or 2 of you might want to try and write in these as decimals. I would advise you not to do that because some of these answers will not be nice decimals. Some of you might try turning them into mixed numbers rather than an improper fraction. Again, I will always just leave my answer as an improper fraction. That is perfectly good enough. 1 or 2 of you will get good at jumping straight from there to what the final answer is. And that is fine. I don't mind that as long as you are getting the numerator and the denominator the right way round. If in doubt, work through it like a linear equation. Let's look at my next example. So let's list the firsts that multiply to make 3. Just 1 and 3. What multiplies to make 9? Well, we've got some choice here. We've got 1 and 9. We've got 3 and 3. Can we see a combination that is going to make 28? Well, I can see 1 times 1 is 1. 3 times 9 is 27, and they combine to make the 28. So let's put all of that in our 2 brackets. We have a 1x and a 3x. We have the 1 needing to multiply by the last that is 1. And we have the 3 needing to multiply by the last, which is 9. And again, both signs, because it's plus there, are the same. They are both positive. So again, we have either the first bracket of x plus 9 equals 0, or 3x plus 1 equals 0. And that is going to give me 2 answers. Either x is -9, or x is -1/3. Again, how have I done that? Well, I've subtracted 1 from both sides. 3x equals -1. And then I've divided by 3 to get to my answer, -1/3. And it's that bit that you might be able to do in your head. Let's look at 2 further examples. 10x squared, take 9x plus 2. What choice have I got for my firsts? 1 and 10 or 2 and 5. But for my lasts, I don't really have any choice. It has to be 1 and 2. The numbers are going to combine to make 9, and I also know the signs are the same. How can I make 9? Well, I've seen 5 times 1 is 5, and 2 times 2 is 4. 5 and 4 make 9. So we have 2x and 5x. The 2 needs to times by a 2. The 5 needs to times by a 1. The signs are the same. They are both negative. And if in doubt at this stage, you can always multiply out with FOIL to double check you have got everything right. So these two things multiply to make 0. It's the same story now. Either 2x take away 1 equals 0. I'll solve that in a minute. Or 5x take away 2 equals 0. Please write either and or. Don't miss that out. It is super important. So this one gives us an answer of a half. And this one gives us an answer of 2/5. Let's look at this final example. 4x squared plus 5x take away 6 equals 0. Firsts, 1 and 4 or 2 and 2. Lasts, 1 and 6 or 2 and 3. How am I going to make positive 5? Well, because the signs are different, this is going to be one where it subtracts to make 5. And I've spotted that 4 with 2 is 8. And 1 times 3 is 3. And they have a difference of 5. So we have an x with 4x for my firsts. I need the 1x to times by 3. So 3 in the opposite bracket. And I need the 4x to times by 2. To make sure that this is positive 5x and not negative 5x, it's going to be plus 8x take away 3x that will get us the positive 5x equals 0. So either x plus 2 equals 0. That's a nice easy answer of x equals negative 2. Or 4x take away 3 equals 0. And that gives us an answer of 3/4. So there are 15 questions for you to try. You'll also see embedded in some of these is some difference of two squares questions. You'll also see in question 1 and question 2, the quadratic has already been factorised for you. So with question 1 and 2, you are already jumping in at the either or part. Have I ever seen that in an exam? I don't recall off the top of my head. Normally, you have to factorise it and then solve. So, as always, use the last few minutes to check your answers and make some corrections. Mark it with a different coloured pen. And if you've got any questions, please ask in the Ask the Teacher channel.